Welcome to this video. I took a break from filming and now I'm back. I'm continuing on with this problem set from a professor at Princeton University. No idea if this professor still teaches there or not, but nonetheless, these are some good problems to try, whether you go to Princeton or not. All right, so I'm on number 13, I guess, or from my PDF of my solutions that I have. It seems like I left off on there. So this 13A or 13 in general, it looks like we're gonna find some Taylor series. Okay, so part A, find a Taylor series at x equals 0 for e to the x squared. Okay, so there's multiple ways you can do this. You can find it the brute force way, which I don't recommend in this case. Hopefully, we remember what the Taylor series and the Maclaurin series is for e to the x. We can work off from there and it will be much easier, all right? So we start off that e to the x is summation as n goes from 0 to infinity, x to the n over n factorial. This is the nice compact form. If you remember the expanded form, it's like 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial plus so on and so forth. This is a power series. Or in a more base or a better way to think about it is this is actually a function. So instead of f of x, what if we have like f of x is e to x? What if we have f of x squared? Okay, so imagine f of x is e to x, so f of x squared would be e to the x squared. Wherever there's x, we replace it with the x squared. So we do that on this side of the equation as well. Okay. So wherever there's an x, replace it with the x squared. That's it. Just this one term, right? And we can simplify this to x to 2n over 2 over n factorial, sorry. And that's our answer, as simple as that. Okay, so this is a typical problem in which we start from a easy to remember Taylor series, and we find a similar one from there. Just treat it like a function, okay? Part B, we're going to find the Taylor series at x is equal to 0 for 1 over 1 minus x cubed. Which Taylor series can we start from? Well, maybe you remember 1 over 1 minus x when we first learned about power series. We learned this one. Equals summation as n goes from 0 to infinity, x to n. So replace x with x cubed. Treat it like a function, okay? And so our power series, our Taylor series is summation as n goes from 0 to infinity, x to 3n. And we're done. As simple as that. Okay. If we do it the long way, if we take derivatives, plug in x is equal to 0, it's going to be much longer. So this is the much faster way. Okay. Now find the Taylor series at x is equal to 0 for 1 plus x quantity squared. Okay, this one, not all schools require you to know this. If you are part of a school or in calculus in a school that requires you to know the Taylor, the one with the binomial, this is a problem for that, okay? If you remember the general form, 1 plus x to the k power equals summation as n goes from 0 to infinity, k choose n, or I always forget, the k choose n or n choose k. That notation, and then x to n, okay? I think it's n choose k, if I remember correctly. I really don't remember, honestly, right now. Okay, so we just replace that k with 2, and you're done. Okay, I think there was part D, right? Yeah, part D, I'll just show everything. Find the first three terms of Taylor's series about at x is equal to 1 for x over 1 plus x. Let me confirm it was x is equal to 1. Yeah, x is equal to 1. Okay, so since it's just asked for the first three terms and not an infinite amount of terms or a general term even, it might be simpler to just take derivatives, plug in x is equal to 1. Okay, because it's only first three terms. So probably you just need to take three derivatives. Okay, hoping that none of them are zeros, then you would have to take more. But okay, let's go through it. So we differentiate, or we don't differentiate, that's like the zeroth derivative, okay? That's just this guy, x over 1 plus x, okay? If we take the first derivative, we need the quotient rule, right? Bottom d top minus top d bottom over bottom squared. If you do that, you get this right here, and it simplifies to 1 over 1 plus x squared, okay? And then we take another derivative. So you can rewrite this guy as 1 plus x to negative 2 power, right? So we do the power rule and then chain rule. You can do it like that, okay? Now we plug in, first, this Taylor series is centered at x is equal to 1, so we plug in x is equal to 1 into these derivatives, okay? So you get half, a fourth, and minus 1/4, okay? So if we remember the general formula for the Taylor series, it's the nth derivative at the center, at 1 in this case, x minus 1 to the n power over n factorial, okay? So if we remember the general formula, so the first term would be the nth derivative, so the 0th derivative at 1, so half times x minus 1 to the 0 power, which is 1, over 0 factorial, which is just 1 as well. So half is the first term. Okay, next it would be the first derivative evaluated at 1, so a fourth times x minus 1 to the first power over 1 factorial, so that gives you this term over here. Okay, and then the second derivative at 1, so minus 1/4 times x minus 1 squared over 2 factorial. So that's this term here. And if we simplify it, it gives you these three terms, okay? And that's it for this problem. Hopefully it was good practice. Again, in my opinion, part A and B are very typical. You can expect this pretty much at any university, at any college. These are very typical problems. Part C really depends on if you went over the binomial series or not, okay? And then this one, I would say is very typical as well. So this problem in general, I would say, know how to do, must know how to do. Not like one of the trickier ones where you might be able to get away with partial credit on some stuff. This, you should definitely know how to do. These are very standard, okay? Please give this video a like if you found this helpful in any way, and hopefully I'll see you in another video as well. Bye.